Okay, here's section 1.2. We're going to look at types of data, categorize them into different things, some with numbers, some without numbers. So this is what we talked about last time. Take sample data, use statistics to make conclusions about a population. So you're going to want to know these definitions. And at the very end of this video, I'll come back and revisit this. Numerical measurement describing some characteristic of a population. Same thing with statistic, numerical measurement, but now it's describing a characteristic of a sample. I'll revisit this at the end. Two big classes we put our data in is quantitative. You need numbers, that's it. These both are numerical data. The other one is categorical data, which I tend to say qualitative because I'm a qualitative researcher. So in my research, I don't deal with the numbers so much as stories of people. And so it's data like this, gender, and how they feel about stuff, mostly mathematics. Two types of quantitative data, discrete and continuous. I'm just going to show you an example here of discrete. Suppose I have some dots. Look, there's gaps in between them, and I can count them. They're countable. I had 1, 2, 3, 4, 5, 6 of them. Now, suppose here's a dot and here's a dot, and I want to measure the distance. Notice there's no gaps. And this distance, it's not countable because really it could be any value in here. You know, maybe this is pi inches. Well, pi is 3.14, blah, 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 blah. It goes on forever. It doesn't end. So things like distance, time, weight are continuous. There you go. Discrete, countable. Continuous, there you go. Infinitely many possible values. Like I said, from here to here, there's no gaps. There's an infinite number of points in between there. So, which of these are discrete or continuous? Okay, I can count chairs. That's discrete. The temperature, well, temperature can range just like distance. There's no gaps in temperature, so that's continuous. The amount of gas in your car, that's a volume. That's continuous, no gaps in volume. Your age, well, you generally give your age as a number, 1, 2, 3, 4. So this is discrete. Foot length, continuous, think of measuring a foot, looks like that. Shoe size, well, you go like 5, 5.5, 6, 6.5. There's gaps, so it's discrete. We're going to do a lab on these, so I won't spend a lot of time on them. I'll introduce each one. Nominal. Nominal, I think of names. I believe that's probably Latin for names is nom. So Categories only. Yes, no, undecided. Gender. That would be nominal level. A step up is ordinal level. Notice there's still categories, but now there's some prescribed order with them where we know that A is better than an F. I'm not going to give any more examples because I want it to emerge in the lab. Interval level. Let's see. They're arranged in order, so definitely I'll look at these two. So there's year 1000, year 2000. So the differences between them, now those aren't the best ones, but if I did 2000 subtract 1000, I can say there's 1,000 years between them. Now this part about no natural zero. If you think about a calendar and the years, what does zero mean? Does it mean no time? No, we just happen to arbitrarily pick that starting point as a zero. So there is no natural zero. Let's do ratio level. Notice we're adding something every time. There's order, differences are meaningful. There is a natural zero. If I think of time, not calendar years, all class goes from 0. When it starts, there's no time. And it can go to 50 minutes. And if it goes to 100 minutes, well, 100 subtract 50 would be 50 minutes longer. But here's the other big thing. The ratio matters. 100 minutes over 50 minutes is 2. It would mean this class is twice as long. You don't get that with these years. You don't say that the year 2000 is twice as long as the year 1000. It has no meaning. So this is your summary. Notice we're adding a little bit. We add a little bit of order. Now we'd say that the differences have some meaning. And I think with the ratio, they should add that ratio has meaning. That's really the big test between it and interval. For instance, twice as long. Now, I said I was going to revisit this statistic. I'm going to take a nominal level of measurement. I'm going to take eye color. Suppose I take a sample of 32 people. 4 have blue eyes. Well, blue eyes is a nominal level. It's just a category of eye color. Now I'm going to change it into a statistic. Remember, this is a numerical measurement of a characteristic of a sample. So what I'm going to do is I'm going to change this now to a proportion of blue eyes. So what I'm going to do, I'm going to say 4 divided by 32. That's the number of blue eyes out of my total sample size. That's 1/8. I believe that's 0.125. So I don't know where the 4 came from. Which you could write as 12.5%. Now you've got a proportion. This is now a statistic. I can talk about it looks like it's the probability or proportion of blue-eyed people is about 0.125, or you could even say maybe 12.5% of people have blue eyes. At least now I've taken a nominal level of measurement, eye color, and I've changed it into a statistic, which is a numerical characteristic. I'm sorry, a numerical measurement of a characteristic of a sample. What was the characteristic? Eye color. What's the numerical measurement? Proportion of people with blue eyes. That's it.